Okay, now we're going to move on to a little bit of ohm meter reading practice. And what we're going to do is indicate what the ohm meter will read when connected as shown. Each circuit is independent, so these are separate. We'll do them one at a time. And all portions of the circuit can affect the measurements shown. Only one meter is connected at a time. Okay, so what we're going to be doing is we're going to be measuring resistance here. So remember, when I bring my meter in, what I'm doing is I'm going to be setting it for resistance. My setups would be here, and basically I'm bringing my leads in, so it shows the first time I wanted to check the meter here, I would check the lead here and here across the switch. That's the way that we would be checking here. So just a reminder, if you were really checking a switch, the operation of a switch, whether it was open or closed or a contact was working, you would probably want continuity, not resistance. Whereas if you were checking a load, trying to get a load across here, then you would want to be checking using resistance on the meter. So continuity checks to be sure the circuit's good. Resistance checks to see if the load is good or bad. So the first one. So we're not necessarily worrying about this meter. We're just looking at this one. So it wants to know what this meter would read for resistance across here. Okay. So in this case, because it is open, theoretically, this is going to read an infinite resistance from here to here. But now, before we get too far, we have to make a point. This circuit has to be de-energized when you're trying to check these. And as a matter of fact, if you really want to check this switch, and it's possible, it might be even better to remove this switch from the circuit so that you are totally isolating this switch. Or if your load, you can remove it from the circuit. You're totally isolating this, okay? Because if for some reason this circuit was energized, well, that means that this side here goes back to a voltage source, and then this side is the other side of that voltage source. So if I were to be checking the left here and the right here, well, we actually do have a path back to each other. So at that point, what are we checking? Well, we'd be checking all the conductors and everything back to the voltage source. We'd be checking the voltage source or the power plant or whatever that's hooked into, and then we would be checking the value of the resistor. So we'd have this big circuit here that we would be checking. And if this was hooked to anything else that had other loads and everything like that, we'd be checking a big mess of a circuit here. So when you check these, you have to de-energize the circuit, and even better yet, isolate the item, okay? So here we go. This would be infinite if it was de-energized because there's no path, it would be dead. The long way around, but the short way right through here would say it's an open. Let's do the next one here. So this ohm meter is going to be checking on the left and the right of a load. That looks good, and this meter's not here anymore. So we can't go either way. There's nowhere else. It would just check that. I'm saying it would read 10 ohms. Okay. Next one. Now, if we did close the switch, and once again this de-energized, because we don't want to take the long way, we would be checking this switch. And in the real world, we wanted to check for continuity, not necessarily resistance, and it would be toning. But if we were checking for resistance, this should be theoretically zero ohms because it's supposed to be a short or supposed to fully conduct across there. And at this point, when we check number 2 with the ohm meter, we're still checking across the load, okay? And it has to be de-energized. You can't have power to this. We would read 10 ohms, okay? The next one, problem C. With the switch open and the circuit de-energized, we're now checking across this circuit here. But because the circuit is open, we are checking across this point here. And because it's open, it's theoretically infinite. With the switch closed, well, we are now checking the resistance across this whole thing. So this is going to be theoretical 0. And so we would actually be checking the addition of these two, 0 plus all the conductors and everything. So we would just be checking the resistance of the resistor. and I would get 10 ohms there. Okay, and let's turn to the next page. A 12-volt battery with a 10 ohm resistor. So here we go. Let's start with number 1. So here we've got a problem. So if I set the meter here and the meter here, well, we're back to that. Hey, you wouldn't be checking resistance of this path here. You'd be checking the resistance of the battery, and that's a problem. So with this energized, ohm meter 1 would read the resistance of the source, which could be very low, but still you've got a problem. That's not necessarily what you want to measure. And if this was de-energized, then you'd be back to checking the resistance of this open, which would be infinite. So what's the answer here if it's energized? Ohm meter 1, I guess you'd be reading the resistance of the voltage source, which would be something, but it's not what you want to do. Ohm meter number 2. So now we have broken this load out by opening the switch. So our flow really can't go this way because it's open. So in this case, we've isolated the load and we've de-energized it. So you know what? We can measure the load. And so we would be able to measure that load of that resistor, and we would get 10 ohms. It's not going to measure the battery because we've isolated it. We've opened it. 12-volt battery with a 10 ohm resistor. Here we close it. So once again, we've got a couple of things going on here. So what we're doing is we're measuring the resistance with it closed of this path and this path. So, which would connect to this path and this path. So we've created a parallel circuit. And so what would the resistance of it be? It would be this circuit, which would be 10 ohms, but somehow it's a parallel circuit, and so we'd have to factor in the resistance of the voltage source. Okay? And that gets a little messy because now we've got parallel, and so we've got to start talking about getting reciprocals of these sources, and it gets a little messy. So that's not what we want to do. We need to either kill the power here or open up a switch or something. So that's not good. Ohm meter 2, same thing. We are not necessarily measuring the resistance of this resistor. We're going to get the path this way and the path this way. So we would be measuring the 10, and we'd be getting the reciprocal resistance of the voltage source. Okay? So that would be a problem. You need to open this switch to get that resistor, or you need to completely kill the power in order to get the whole thing. So hopefully that makes sense to you.